I love coming here. So much of life is about finding your people, and I spent a long time trying to figure out where my people were, and they're here.
Hi, I'm Brody. I'm here to peer pressure you into using Address Sanitizer. I was originally going to bully, but I feel like that's not within the code of conduct of this conference. All right. So Address Sanitizer, also called ASan, is part of the compiler. You will compile your code with ASan enabled, and it will add extra instrumentation to your code. Then when you run your program, those checks, that instrumentation, will detect various memory issues, memory errors. So it can detect overflows, writing or reading outside of buffers that are on the heap, the stack, global. Notice that Valgrind can only do the heap. Some standard containers are instrumented, and then it can detect use after free, return, and scope. It can also detect initialization order bugs and then memory leaks, although that's through leveraging a different sanitizer, but it's on by default on Linux. So it was initially introduced in Clang and then added to GCC. I don't personally use Xcode or Visual Studio, so I can't comment on that. But I will point out that those versions of Clang and GCC are pretty old, so you probably have it on your compiler. And then depending on how new your compiler is, you might have more checks that were added later. So basically how to use it on Clang and on GCC, you pass fsanitize equals address. You might want to optimize a little bit, and then G, and you want your frame pointer so that you get nice stack traces. I didn't include a slide with the stack traces because they're quite large, but say you get a double free, you'll get a stack trace of where it was allocated, a stack trace of where it was freed the first time, and a stack trace of where it was freed the second time, which triggered ASan. Out of the box, ASan on Linux pretty much does what you need it to do, at least for finding low-hanging fruit. But as you get further along, you might need to, fiddle some knobs, change some values. So you can set an environmental variable, key value. So on ASan, maybe you set help equals true, and it shows you what you can use. And then for LSAN, for finding leaks, you can set exit code equals 0. So say you have a code generator that leaks, but you want to get all the way to the end of your actual, you want to get through the build step, but you still want to know about your leaks. You can set it to exit 0, so it'll print out about the leaks, but it won't fail when it won't exit with an error code. So there's some limitations to it. There's a slowdown of, according to the wiki, about 2 times, but that's still 10 times faster than Valgrind. I do like Valgrind though; it's a good tool. The binary size is increased because they're adding all this instrumentation to it. It maps a lot of virtual memory. And then you have to recompile your program, but I mean, you're developing, so you need to anyway, but it has to be part of your build system then. And then I think the most important thing is this is only as good as your code coverage. So say you're running your unit tests in CI and you enable ASan, one would hope that you have good unit tests that cover everything, but you may not. And so yeah, the coverage is it's only as good as the coverage you get. There's a couple advanced things that I'm only going to mention that they exist, but I'm not going to explain them. You can add an attribute to functions so that they don't get instrumented. You can add a suppression file with a somewhat limited syntax. I think it's worse than Valgrind, so 1 point for Valgrind. There's an ASan interface that lets you call into parts of ASan that you probably won't need. And then just a thought, fuzzing. You could do coverage-guided fuzzing with ASan enabled. That way, you don't just hope you get a crash, you will definitely get your program to exit when you, say, read past a buffer. Oh, and one thing I'll mention, the whole point of fixing these things is A, your program crashes less, and B, your program's more deterministic, which are all things we desire. And then once you're done with ASan and the leaks, you can go on to the other sanitizers. There's UVSan, it'll detect things like pointer misalignment, vputter mismatch, shifts that are UB. LeakSan will run as its own separate tool. TSAN is for data races. It's a very humbling tool. You will run your program with TSAN. You'll see a ton of output. You'll feel bad about it. Then you'll go to YouTube and look up Herb's talk about atomic weapons. And then you'll kind of understand some stuff about why TSAN's complaining to you. And then there's Memory Sanitizer, which finds out which tells you when your program is influenced by uninitialized data. So conditionals, indexing into memory, and libraries. Thank you.